Share screen, come back over to the terminal here. Okay, like always, you all are going to be grading your own quizzes. Quick aside though, before we do that, last time there were about, I don't know, quite a few people, more than 10, I think, who gave yourselves partial credit on problems. And I took away all that partial credit. And if you, please don't do that on this quiz. If I see that again, it makes it more annoying for me to enter the grade. So I'll just put in zeros for people's quizzes. So all the points, all the problems, just in this case, they're going to be worth 2 points each, so either a 2 or a 0. Up here on our terminal windows, I've got 2 terminal windows open, and they're both into our SQL quiz folder. You notice that I created a new branch right here, quiz 1, get branch. In general, anytime I'm working on a project and I'm doing something different than I've done before, I'll always put that inside of a new branch. And so all the files that I've added here in particular are quiz1.sql file right here. That is only in this quiz1 branch, which isn't currently on GitHub. I'm going to go ahead real quick, git checkout master, git merge quiz1, git push origin master. Got that in the clipboard. Oh, I didn't have it in the clipboard. Okay, I'll push it up to GitHub in a little bit, but you'll have access to the quiz after class is over, should you choose to want to look at it again. In order to run all the quiz problems and talk about them, down here in the bottom terminal, we're going to run our Docker command. So Docker PS, we can see that nothing's currently running. Docker compose up-d, run it in the background here. And now change that to an exec pgp SQL like that. And we've got our pSQL terminal running down here that we can run our commands in. And up here, let's open up the quiz1.sql file so that we can actually see what the commands are. The very first problem here, in order to figure out what the problems are going to do, I'm going to, again, first take away, anytime we have the aggregate functions, we'll run the problem without the aggregate functions. So even we'll run it without the where clause here. First, just get all of the IDs from the basket where ID is greater than null. Little trickiness going on here. Again, whenever we have the null operator, whenever we have null comparing with one of these equality operators, this is always going to give us false. This will always evaluate to false over here. The greater than null would never make sense. So maybe less tricky than the equals null, which would also evaluate to null. You have to use the is null keyword if you actually want to find null things. And so this command right here, without the count, without the distinct, just gives us no rows. So the final answer when we run problem 1 here is just 0. And if you wrote it out as a table with count and 0, that's good. If you just put the number 0, that's also okay for this problem. Any questions on problem number 1? Okay, more interesting problems. Problem number 2, very complicated looking one here. Let's do a real quick set no number so that I'll be able to do some copying and pasting here. And again, anytime I have any of these clauses or any of these problems, we can understand what's going on by simplifying them. We'll start by with the having. Recall that that's the last thing that's going to happen. So I'll start by removing the having. And I'm also going to remove the group by right here. And we'll start with just this query right here, selecting all of the fruit A's that satisfy this particular condition right here. So we'll run that and then we'll talk about it. Run that. And so here you can see that it is the I for insensitive. So we're finding things that are like this expression here. They have an A, insensitive, so it gets both apple and the banana and orange. And now when we do the group by over here, group by will allow us to do the count aggregate function where it counts how many things have the same value. And so here the apple will go to 2, and then banana and orange going to 1. Rerun this like that. And we get the apple now with the 2, banana and orange with the 1s. And then we add our halving clause in to get back to our original problem. And in this case, the halving, so again, the difference between the where and the halving clause, the where happens before the group by, so it affects the what we're grouping by. The halving clause does not happen before the group by, it happens afterwards. And so it filters the results of this table that we're looking at down here. Our condition over here is the count star. So it's this rightmost column, and we're looking for things that are less than or equal to 2, and everything is less than or equal to 2. And so when I run this, we'll still get the exact same results over here. And so for this problem, I'm expecting you need to have the apple and the banana and the orange listed with the correct numbers next to them. If your table column names are different, or you didn't bother writing out the table column names, that's okay. As long as you have these 3 lines with those numbers and words in that order, then you get full credit on the problem. Key idea of this problem, again, is that the halving clause happens after group by and the where clause happens before grouping. Any questions on this problem? Number 3, here we go. So we have another count here, this time with a join clause. Again, the join clause is syntactic sugar for the cross join plus an additional where query. So we could rewrite this as a cross join right here, taking off this using clause and changing it to an basket A.id equals basket B.id. But the using clause over here, also syntactic sugar for an equality constraint comparing 2 columns with the same name between 2 tables. In this case, well, yeah, so the reason for wanting to understand the syntactic sugar of the join clauses is really when we get into the left and right joins. With the inner join, at least for me, I think it makes sense to sometimes just go straight to understanding what it does, finding rows that are the same between both columns. But we'll start here with the cross join in this case. And to really simplify things, I'm going to take out the count star and this extra condition right here. So the only thing that we'll look at first is the actual cross join itself right here. And let's run that down here. And these are our results. Again, if we do the cross join by itself, so just these first 2 lines, it gets me all, what are there, like 56 of these rows, where each row is, you take the first row of the basket A, the left table, and match it with every single row from the rightmost table. So it's like a cross product in set theory. And then we only keep those rows that satisfy this condition, the basket A.id equals basket B.id. And so we'll keep this one, discard all of these. And in particular, at the end, when we have nulls everywhere, we'll be discarding these nulls because null is never equal to null, just because of the weird properties of null. So yeah, close that. After you get the equalities, just keeping the same ones from both sides, this is what we're left with. And so now, before we get to the count star, we'll add in this last constraint right here. This constraint actually is meaningless because the equality right here is already filtering out things where ID is equal to null, or where ID is null. Because again, if the ID was null, it would be an equal sign right here. Null equals something, and so that would be evaluate to something falsy. So I'll comment that out, rerun this command right here, and you'll see that we get the almost the exact same results. In this case, when we're using the using clause, I can just reference the ID without a table name, because this is guaranteeing that they're going to be the same everywhere. Here, there's no using clause. I have to specify which table name I care about. It won't actually matter though, so I'll just specify basket a.id like that, rerun this. We get the exact same answers down here, again, because this clause is meaningless because it's already included inside of this clause right here. And so finally, let's run the actual count star. We have 5 rows from our previous stuff. So if we did everything correctly, which we did, we get our 5 as our final answer. And so again, as long as you have the 5, then you get full credit. You didn't have to write out the column name for this problem. That'd be okay. Any questions on this problem? Okay. One last problem, number 4 down here. This one I think is by far the hardest of them because of this weird constraint, this weird joining constraint. And a lot of the, if you've been introduced to SQL joins in previous classes, the way they are typically introduced is not with the sort of more formal equivalents to the cross join like we've talked about before. And so complicated join expressions like this are really don't make sense unless you know how to go back to the desugar this to go back to the cross join expression. So let's go ahead and do that. Copy this down here. And again, we'll start by taking away the aggregate functions, and then we'll work on our desugaring right here. So basket A, basket B, cross join like this, and then the on gets converted into a where clause like this. We'll start off again, just for fun, only on the cross join. We've already seen this before. It's a little bit different now. It is a little bit different now though, because we are selecting different columns right here. So we still get the 56 rows, but there you notice there's a lot of duplicate columns going on because we're only selecting right here the ID from basket A. And now in this where clause, we'll be looking at whenever the basket A ID is greater than the basket B ID, and find all of those situations. I selected this clause in particular because there's not many. It really filters down the total list of things. And so here are the valid values of basket A where they can be greater than something in basket B, 2, 3, and 4. In this case, you rather than like writing out the whole table and simplifying, you could know that the basket A, all the things from basket A are going to get joined from all the things from basket B. And so as soon as like the 2 in basket A, that's greater than the 1 in basket B. So everything inside of basket A that's greater than in 1 must be kept down here. So we have 6 rows in this just from the inner join right here on this really awkward greater than clause. Now, the last fun part is doing our count distinct. Again, the distinct operator is going to first remove duplicates. So we have duplicate 3s and duplicate 4s. There's only 3 unique values. So it'll remove those duplicates and then only apply the aggregate function to the unique values. So it's you don't need to add it back in because we already have it up here. We're finally ready to run the entire problem. And we get 3 as the result because there were 3 distinct values up above. Any questions on problem number 4? Okay, go ahead. Again, each problem 2 points. It's either a 2 or a 0. Total up your score and pass those quizzes up to me. Any other quizzes for me? Okay. Here we go. Reset. Okay. Today in class, announcements. We've got a handful of announcements for us before we get into technical stuff where we left off last time. First thing, 2 announcements posted as issues today. I have a handful of summer research projects which may or may not be interesting to people in this class. 2 of them about interesting things related to North Korea. We'll be talking about Unicode and database Postgres support here in a couple weeks, but it's essentially the way that foreign languages are represented in on computers. One of the nice things about Postgres actually is that it's always had fully accurate Unicode support, and it's the only database actually that's can say that. MySQL, the other popular Postgres competitor, has not had Unicode support until extremely recently, like only 1 or 2 years ago. And actually they advertised they had Unicode support, but if you inserted some characters that they didn't support, they would just drop the data from the database and your data would go missing. It turns out though that there are certain things in the North Korean language that are not represented in Unicode and so can't be supported in any database right now, or in Python or Microsoft Word or any of these systems. And it's not too hard to add things to Unicode, and I would like to do that. Maybe concrete application of this is that there have been times when North Korean and US diplomats have been trying to communicate with each other, like emailing each other documents, and they can't open each other's documents because the North Korean system's not compatible with what everybody else uses right now. Number 2, archiving North Korean web pages. A lot of well, there's this thing called the Common Crawl, which I'm not sure if we're going to get to at the end of the semester, which archives a lot of web pages. Also the Internet Archive, and they need some help archiving North Korean web pages, and so this second project is about that. And then the last project is more machine learning related with ChatGPT or a bunch of other systems, getting them to read and write in better support for non-English languages. And in particular, a lot of the methods that people use right now for these systems essentially are trying to give them like huge, massive amounts of data. ChatGPT, for example, is trained on essentially every English sentence that's ever been written. And that's not at all like how people learn to read and write language. And so I'd like to use these existing systems and feed them some textbooks designed for people in order to teach them in a more data-constrained environment the same way, or in a more similar way to how people learn things. So I'm going to be working on projects like this over the summer. Yes, question? Question, will I be teaching a machine learning class? At CMC, we call it our data mining class, and it's normally offered in the falls. I'm not going to be here next fall, so I wouldn't be offering it next fall. Somebody else will be. It'll be a visiting person who's not been hired yet. We don't know who it will be. And I'll be teaching the data mining class again in 2 years from now. The data mining class that we have here is more in traditional machine learning tasks and not into quite yet the deep learning stuff. One of my hopes is that, so we were previously hiring somebody, still in the process of hiring a permanent faculty, and we'll have a regular visiting CS position. My hope is that with all these new faculty people, we'll be able to offer both a traditional like machine learning, pre-deep learning era stuff and a deep learning class here in the future, but not yet. Yes. Question is, are they open to graduating seniors? Possibly. The actual like summer research program hasn't been, their details haven't been formalized yet. I think they're going to announce the program to students like in a month. They try to do it, I think around like they target spring break-ish time as when they announce it. 2 things that I've been trying to convince them to are that graduating seniors be allowed to work on it. So it's a better transition potentially into like a job somewhere. So you have time to, yeah, don't have to stress out about jobs quite as much. And also in the past, it's been non-CMC, only open to CMC students and not to other colleges students. I've talked to the people who run it about both of those things, and they say they are supportive of me trying to do that, but we'll see those details. Outside of the official summer research program, I may or may not have other sources of funding to be able to hire people who fall into those other categories. Good questions. If you have any other questions about any of these, there's links in here to read more up about things. You can feel free to read them, and we can chat about the topics, projects more later, and if they might be a good fit for you. Another announcement: this Friday evening at 7 to 8:30 p.m. I will be talking about my time in North Korea. So again, I was there from 2015 to 2016 teaching computer science in Pyongyang, and I actually still collaborate with a bunch of people from North Korea. I'm hoping that actually this summer we'll be publishing something on North Korean cell phone infrastructure, and we've developed some new like cell phone techniques that their buildings there are all like super heavy, thick concrete, like 10-foot thick concrete structures, so cell phone signals don't get in very well. And so we've been designing cell phone systems that work for buildings like that. This Friday, though, I won't be talking about technical things. Instead, I'll be talking about my time there, sort of like more personal experiences, and interacted with a lot of Christians in North Korea, a famously closed off, anti-religious country, and what that was like. So that'll be 7 to 8:30 at the Founders Room in the Bauer Center. More announcements are posted. So topic 5 is where we're at right now. I just realized actually that I forgot to post this, the README file on Monday's class, because we just went straight into the SQL notes. But here it's been posted now, and so I have a handful of announcements listed here. The first one is one of my favorite stories, and I'm embarrassed that I forgot to share it earlier when we were talking about the glob operator. And this is that, so a Pixar employee, by using the glob operator incorrectly, they accidentally deleted the entire Toy Story 2 movie. And so Pixar, like one of the employees, an animator, actually deleted all of the movie. They were extremely lucky that one of their employees who was on parental leave stole the movie from them, and so they had a local copy on their laptop at their house, and they were able to recover like 70% of the movie from that, and they were able to finish production and make it to the theaters. What? Did they fire the employee? I believe the employee is a vice president at Pixar right now. If you want to read about the story, so there's a pretty good write-up about all the social details here, but it specifically goes into like the technical details here. You can see that somebody ran this rm-rf star command in the wrong folder. They didn't realize where they were at, so the glob captured more things than they thought it would. And it was running for a long time, and so rather than figuring out what was going on, the person just walked away from their computer and got lunch as it progressively deleted everything. And then they suddenly heard shouts from like the office about why my file is not existing, and they panicked and ran back to their screen and pressed Control-C as fast as they could. But where is it? 90% of the movie had been deleted by the time they stopped their RM operation. And at the time, Pixar did not have any backups of their things, or they thought they had backups, but they tried to restore from the backups and were unsuccessful. So in order to, somewhere it talks about the employee who had stolen the movie from them, and So fun story about the glob operator. Normally, when I do the glob quiz, I make very severe negative penalties for getting the wrong answer. I forgot to do that this time though, because I forgot for us to talk about this story. So hopefully you all remember that when you're using the glob to be very, very careful, especially when it's like an RM command deleting things, because you can destroy a company by using that one command incorrectly. Friday, we will, no lab assignments. I think we'll probably finish up today everything we need to finish, but maybe not, in which case we'll have, I don't know, 10 or 15 minutes of lecture stuff, but the rest of the time will just be available to work on Friday. Also this week, you should be like thinking about focusing on having a good workflow, going through all of your assignments, being doing things that feel lazy. Like if you're doing the same repetitive task over and over again, you're probably doing something wrong while you're working on these assignments. Here's Bill Gates saying he likes hiring lazy people because lazy people will find an easy way to do things. Larry Wall is the inventor of the Perl programming language. This was like, in timeline wise, it kind of sits between Bash and between Python. Perl ran most of the internet in like the 90s, but it has since gone out of fashion due to Python being a nicer programming language. But his chief virtues of being a programmer are laziness, impatience, and hubris. And so you should practice all three of those qualities while you're working on the assignments. And again, when I'm going to be doing all of our notes in class, trying to demonstrate one of the reasons why I'm using the terminal a lot and not say like PowerPoint slides or writing on the board is so that I can demonstrate to you all what like these good lazy practices are, and trying to imitate these practices would be a good habit for you all. Okay, almost done with announcements. We're getting into like semi-technical announcements now. This is in the last week's topic 4 README file. There's a little bit more just high-level stuff that we didn't cover yet, this comparison of the main database systems. And so we'll talk about this now before getting into finishing up what you need to know for the SQL quiz. This first pleasantly named link over here about how fucked is your database has a list of very popular databases that people use. And I mean, it's not a very pleasantly named thing, but it captures the sort of sentiment among actual database people about why you might or might not want to use any of these databases. So we'll start with Oracle. This is probably from the like econ department, the most famous of the databases. And Oracle, it's okay, but licenses for Oracle cost millions of dollars. And so if you have millions of dollars to spend, then that's good. Turns out that there are a bunch of laws written in the US and other countries that require certain types of companies to use Oracle as their database, and it's illegal to use other databases. And so that's why Oracle charges millions of dollars, because the law says everybody has to buy from them. So banks tend to use Oracle. MS SQL is another popular one in the econ department here, also called SQL Server. And this one is notoriously awful. It's famous for a number of disasters, but one of them is that there was a nuclear reactor that internally used Microsoft SQL for things. And that nuclear reactor had a nuclear incident because of pressing too many buttons. Back button. The nuclear reactor had a nuclear incident because of data loss issues in SQL Server. And so nobody serious uses SQL Server because not only does it cost money, but it throws away your data when it feels like it. And again, we said before that even Microsoft does not use SQL Server. They use Postgres when they actually care about their data. So if Microsoft's not using it, their own product, then you probably shouldn't use it either. MySQL is probably the most popular competitor to Postgres. If we click here, then you'll see that the database community does not like the MySQL Server database system in general. And the reason for that is because MySQL will just discard data that without actually like generating error messages for you saying that it is discarded data. And so that makes it easier for people to set up and use because there's fewer error messages. But if you care about your data, then you probably want to have an error message when your data is being thrown away. So MySQL used to be more popular, not very popular these days. Facebook famously uses MySQL in its back end, but they've made a number of extensions to MySQL at this point so that they don't use it anymore. Postgres is now the standard thing that most new companies are using. This thing called Sloaney is, I don't know, a thing that people like to make fun of. So if you press yes, it'll make fun of it. It says you're probably okay. Again, database people were very conservative. I say we, I don't really consider myself a database person. I'm more of a machine learning person. But database people are very conservative about the data. And so we will never say like a hard guarantee, like I guarantee your data is going to be okay. We'll only say that it's probably going to be okay, meaning that, so we'll talk about exactly some of the things that it does for data security and integrity here after the midterm, but probably means that somebody can come up to your computer while it's running and smash it with a hammer, and Postgres makes guarantees that the data will still exist, even if like catastrophic disasters happen. Other than Postgres, SQLite is the most common, well-regarded alternative. And here, the main disadvantage of SQLite is that you can only have one person using it at a time. So that's if you're in that situation, then SQLite is the thing to do. If you need more than one person accessing it at a time because it's like a web page, then install Docker and use Postgres is the thing to do. There's been a trend recently in NoSQL databases, and I'll have a bunch of more fun links about this later on in the course. The Guardian newspaper used to have as their database backend a NoSQL database called MongoDB, and they because MongoDB is not actually a database, not SQL database, doesn't actually guarantee data integrity. A number of their news articles have been lost forever because the data was not stored correctly in a database. So that's just more background about why people like Postgres in general. In maybe more concrete numbers, there's this well, this link at Stack Overflow, they do regular surveys about technology that people are using. And there's a very long document here. I don't know, it's pretty interesting. I'd recommend taking a look at it. But the highlights here for our class are at the very top. The thing they really want to highlight is that Docker is just growing in popularity here, and people are wanting to deploy Docker at companies that don't currently use Docker. So that's one of the reasons why we're using Docker in this class. If I take a look at their most popular programming languages, so up here, JavaScript, HTML, everybody has to use that because that's the only way to display a web page in a web browser. SQL is the second most popular, or I guess the third most popular technology here, because anytime you're interacting with a database, you have to use SQL no matter what database system you're looking at. Starting today, maybe Friday, we'll start to see some of the major differences between Postgres and other databases in terms of the SQL language itself. And then in terms of like actual traditional programming languages, Python is the top there. Scroll down a little bit more here. Question? Question is, what's the difference between Postgres and Apache Spark? The answer is that there's many differences. Apache Spark is the main thing about Apache Spark is that it is a system for doing MapReduce type jobs. Well, so there's a lot of systems like that. So there's Apache Spark, Hadoop, also from Apache, and I don't know. I can't even remember any of the other names. There's dozens of them that people use. My sense is that, well, I've never personally met somebody who thought that they were using that technology appropriately at a company. But people who, like administrators at those companies, like to use those technologies because they, in their PowerPoint slides to investors, they can say like Apache Spark and things like this. But one of the goals of this Twitter assignment, this Twitter MapReduce assignment, is for you to see that like the shell by itself can do everything MapReduce wise that things like Apache Spark or Hadoop systems can do. And 99% of use cases really just going to the shell or to Postgres is the thing to do. Apache Spark does not have a full featured like SQL interface the same way that Postgres does. Does that sort of mostly answer the question? Yeah. So I don't know, there's another sort of key catchphrase that people throw around these days, which is resume-driven development. And so if you're at like a small company and they don't really have a lot of data, they only have terabytes of data, people will start using things like Apache Spark so that they can try to more easily switch jobs to a place like Facebook, where it makes more sense to have these automated systems. But there's, I don't know, hundreds of blog posts on the internet about how somebody has taken their an Apache Spark system that somebody's built previously and just replaced it with a 3-line bash script and saved their company millions of dollars a year in compute by doing that. Okay, back here real quick. In terms of like the databases that people are using, if you look at the all respondents here, so this is especially people learning to code, you can see that MySQL is the most popular database. Postgres is kind of down a little bit lower, but if you look at professional developers, then Postgres is the most popular database these days. MySQL here being a close second. Is that the last? Yeah, it's the last. Well, okay. Web frameworks real quick, since we talked a little bit about Flask. Flask and Django, the two Python frameworks, popular Python frameworks these days, both about equally popular for people doing things. All these other frameworks up here are non-Python things. Okay, that's it for the non-super technical stuff today. Question, yes. Question is, do we have a homework assignment due this Tuesday? And the answer is yes, you have a second Pagilla homework assignment due this Tuesday. Yes. Well, I guess the link is not right here. It's just if you put a 2 after the Pagilla, then it'll take you to the right spot in the URL. I'll put it up here after class. The main difficulty of the main things that the second the second Pagilla homework is going to be testing are these like set operations, like the unions and the except, all the things that we talked about so far in the quiz, plus the outer joins, like the left and the right outer join, and the subqueries. Down here in this lecture section, it's got references for you if you want to see references on all those topics. The main thing that we're skipping on our postgrestutorial.com is this section 6. There's special syntactic sugar for various group by clauses, which we're not going to go over. I don't think those are hard concepts in the same way that a join is the hard concept. They're not really fundamental to how databases work in any way. And so that's why we're not covering. We don't have time for it. They're not very popular in what I would think of as like a real technical interview situation. So like if you're going to like a FANG company and they're asking SQL questions, you're not going to get questions about the stuff in here. But if you're going to like a less technical sort of place where they're not maybe like a really a data oriented place and you're one of the few data people, then this is one of the topics that is somewhat easy for them to test on without knowing the details of SQL. So common to get interviewed on these things. Subqueries, we've pretty much covered everything about that. We're going to see maybe the end of today, maybe on Friday, is comparing subqueries to joins in terms of their power. We're going to see that in general, subqueries are more powerful than joins, that some subqueries can be written as joins, but there are other subqueries that cannot be written as joins. I've talked about set operations, and we're going to finish talking about our left and right joins today. The last concept in the Pagilla homework, which is not in the quiz, is this arrays concept. This will be something that is unique to Postgres, not inside of any other SQL database. Okay, in order to talk about these concepts, we're going to go over here back into the same SQL quiz repository that we were in before, and there's no new files here to download. The same, if you were following along in last class, you can keep following along without re-downloading anything else. We're going to look at this quiz practice 2.sql vim quiz practice 2.sql file. Again, I often when I'm reading out a file name, the characters here are important, that it's .sql. But if you're talking about the language itself, then it is a SQL. The language is SQL. The file extension is .sql. Let's open that up, and where we left off was we were talking about the idea of left joins. I just mentioned that that was syntactic sugar for various combinations of union and except and our set operations and various subqueries. So we're going to go over that in detail today, see exactly what this syntactic sugar is doing and how to interpret it, and that will fill up the rest of our time. Are there any questions about the setup of the problem that we have right here? Okay, so I've just opened up a pSQL session down here, /d. We still have our basket A and basket B. Format of the quiz next week on Wednesday is going to be the same format as it was this week, still worth 2 points per problem, so 8 points total. And now we're just going to have more SQL things that can appear on the quiz. We'll start with this, this left join right here, figure out what exactly is going on. Set no number here so we can copy and paste. And every time, well, let's see. There are some intuitions about the left joins. Every time I try to think about what those intuitions mean or are doing, my brain is just not able to handle those intuitions, that it seems like I can get the intuition to work in some cases, but not in other cases. So for me personally, I always have to go back to this syntactic sugar and figure things out based on that. So this left join right here, we're gonna copy this syntactic sugar right here, and we'll go through it slowly, figure out exactly what's going on here in order to understand exactly what that left join is doing. In order to understand this syntactic sugar, I'll start by copying that and pasting it right here. And I will translate this, this left join into the syntactic sugar, or I will desugar the left join using this as our guide down here. Again, you will have for your quiz, you'll be able to have the printout of the of these notes in front of you. And so the way to be taking notes right now is to figure out, make sure that you're able to do this desugaring as you need to do it for the quiz. And so whatever you need to be able to take you from this to the desugared version is what you'll want to write down. Here, the key thing about the left join is that it starts from an inner join. So select, count, start. I'm going to rewrite this as one line so that it's makes a little bit, takes up a little bit less space, but it starts from a inner join with the same information, basket B, using ID like this. And then there's a union all with some other stuff right here. So the first step towards understanding the left join is that it contains everything that the inner join did, plus some other things appended to the bottom down here. What are those things that are appended to the bottom? Here, and let me remove the count right here. What are those things appended to the bottom? There's two more select statements that we'll have to understand. This first select statement right here is selecting everything from the original list right here. This is selecting everything from the original list. So we'll write that select basket A dot star, comma null from basket A. So we haven't seen the dot star notation before, this notation like this. What this is meaning is that this is going to be all of the columns in the basket A, table. So if we do select star from basket A like this, there's two columns in the basket A table. So this is going to give us two columns right here. This star up here is actually going to give us four columns because, again, when you do the inner join, it takes all the columns in the left-hand table and all the columns in the right-hand table and horizontally concatenates them. So here, if we do that, you'll see there are start with the on version, basket A.id equals basket B.id. There's four columns here. Two columns from basket A, two columns from basket B. When I had the using syntax, it collapsed the IDs into a single column. So actually I should start up here with also the on basket A dot ID equals basket B dot ID like this. I have these two null columns right here because these two null columns in this query right here correspond to the columns over here in the fruit B, basket B table over here. We're adding null columns over there. Again, in order to use the union, all the columns, the number of the columns and the type of the columns between the table down here and the table up here must match. So I have to add these null columns to the basket A table in order for it to have the sort of same shape as my joined table up here. I'll just run this real quick to make sure there's no syntax errors at this point. Oh, I have an extra comma right here. So delete that. In order to get to that line, again, in Vim, if you press, this is one of the most common horizontal movements that I do, is that if you press Shift F and then the character that you're searching for, it'll take you to that character going backwards. Shift F, then the character, F for find, takes you backwards. And the Vim heuristic is that anything capitalized goes backwards, anything lowercase goes forward. So Shift F, comma, takes me to commas backwards. Lowercase f, comma, takes me to commas forwards. So let's run that again now. Oh, I forgot to delete that, an X right there to delete it, recopy and paste that. Okay, now it's working and you can see that we get these null values right here. These nulls correspond to all these. Are there any questions so far about what's going on? The syntax that I've written out? Okay, then what we're going to do is we're going to include everything from basket A except the things that match this condition down here. So except all. It's important that it's an except all and not just an except, because we don't want to be removing duplicates. And then this condition down here, select basket A dot star comma null from basket A, join basket B on whatever our condition was. What was it? Basket A.id equals basket B.id. And here, what this is doing is this is let's go ahead and run it, and then we'll talk about what it's doing, where we can see the output right here. This should be like striking you as very similar to this select statement up here. They're both joins up here, join up here, join down here. Same exact condition, same exact tables. The only thing different is the actual columns selected. But over here in this bottom one, we have nulls in the right-hand side. And up here in this top one, there's no nulls anywhere in the columns. So this right here, very, very close to being our very close to being our original join up here. Very, very close to being our original join. The difference between this join down here, this bottom join, and this top join up here is how null values get handled. Recall that up here in this equals condition, the null is never going to satisfy if basket A or basket B's ID is null. This will never evaluate to true, and so a null value will never get contained in this original select statement. Down here, however, null values will be contained in this second right here. And sorry, the null value at this point is not contained. It's just adding this one extra item right here that's not in the original list, because the basket B was equal to null. We just haven't displayed it right here. But here, basket A is not equal to null. Now, when I do this except all, so here, this top row right here, this is everything in table A, and then we're going to take out everything from this condition right here. The types match again, the right-hand columns just being null, so we really don't care about them. The only thing that is important is the basket A part over here. And you can see that the basket A part over here is not having the nulls in the ID column, because the ID column right here does not have nulls. But when we do this except all, we will take out all the non-null ones. So this 1, 2, 3 right here, we'll take those out, and we'll take this out, and we'll only be left with this null row and this null row right here. Run these 3 lines. And we're just left with the null rows right here. In this case, what this is going to do is we're going to, up here, this first line, not get any of the basket A nulls, not get any of the basket A nulls in this first line. And then the union all is going to add in all of the basket A nulls for us. So run that. Union types integer and text cannot be matched. That works. Select by cannot be matched. Where do I have a type error? Gonna try. Again, the error messages here in Postgres, super annoying. Integer and text cannot be matched. Why are you? So it's line 4, this null right here. You're telling me that it's trying to think it's a text when it should be an integer. Let's go ahead and call you an integer and go ahead and call you a text. And there we go. So I had to explicitly typecast this null here so that it would combine up here correctly. But here's the final results. Still the same as the inner join up here, all the stuff from the inner join plus these two null rows down here. Any questions on the mechanics of that at this point? Okay. So this is the formal definition of the left join right here. If we run this, now run the previous line right here, removing that count star, we'll get the hopefully same results right here. In this case, I used the using clause. Come on, zoom. The using clause up here, so it collapsed those on basket A.id equals basket B.id, collapse the IDs together. That is the same as this big long desugared thing. Same results. Yeah, so for me, working these sorts of problems with left, right joins, outer joins, this is the only way, desugaring it, that I am confident in my answers. There are various heuristics that sometimes work, but not always work. One of the key things about left and right joins that's different than the inner join is that the inner join is commutative and the left join is not commutative. So the inner join, commutative, left join, not commutative. So commutative means that it's the same no matter which order you apply the join in. And so right here, if we rerun this as a count star like this, count how many results we get, 7 results here. If we rerun that with basket B on the left and basket A on the right, you'll see that we get 9 results instead of 7 results. So it can't possibly be the same table when you reverse to these two things. Yeah. Any questions? Yes.
What would count for a left or right join be the number of entries in your first table that you're joining on? Like if you do basket B left join basket A, will the count just be the number of columns entries in basket B?
So you're saying that here we have a left join on basket B and basket A, and here we have a select count star from basket B, and you can see that those numbers are not the same.
What row is it? Where is it adding an extra? This isn't only the things that are in basket B.
Question is, where is this extra row coming from? And this is related to those like heuristics that people talk about, and especially in like introductory SQL courses, they only talk about the heuristic. Here, it's related to the fact that we have some duplicate rows, that the Apple A right here is here 3 times in the left join version, but in the not joined version, it's only there twice. I don't have any good like intuition about how to explain why that's the case, other than you have to go back to this is what the left join literally means, and use that. That's a great question. Any other questions so far? Okay, so this syntactic sugar is like has no intuition at all to it, basically. I can't think about this syntactic sugar and come up with an intuition about what's going on. Fortunately, there's a slightly simpler syntactic sugar, this second one right here, which works in all the cases of actual interest. The cases of interest being when your condition is an equality condition like this. So this is the actual condition where you have a single equality condition. If you do not have an equality condition, you cannot use this shortened version of the syntactic sugar. You must use this more complicated version up here. In this simpler syntactic sugar, we're basically replacing this except all clause down here with a not in and then a select right here. So in words, we're taking everything from the interjoin, and then we're adding all of the things in the first table that are not in the second table. So the left join takes everything from the inner join and then concatenates. So union all is concatenate everything from the first table where that condition is not in the second table. So this is a much more intuitive syntactic sugar. This is the thing that when people are doing most left joins in practice or right joins in practice, this is what they're actually thinking of. For your Pagilla homework, this is the syntactic sugar that you should be thinking of about using joins. But for your quiz, I will force you to at least once go into this true definition of the left join in the general case up here. Thinking about this version of the syntactic sugar right here, let's copy this. Do it right below here, and we'll work through what this is doing. And actually, I'm just remembering I have a slight typo in this syntactic sugar, which you'll want to annotate on your notes, and we'll make sure to highlight that when we get to it, because it's an easy typo to make. So again, here on our, let's see, does that work? I forget how to do a reset command, clear my screen in pSQL, so we'll leave it how it is for now. We'll do the poor man's clear the screen, hit enter a bunch of times. Run the our left join and take a look at what it looks like. This is joining the basket A to the basket B. And I want to do it without the count star so we can see what the things are. And again, the intuition here is that we have all of the things from the inner join plus all the things that did not match the in table B here. Here, if I do a select, so let's go ahead and write this out. Select star from basket A, join basket B on basket A dot ID equals basket B dot ID. So this first line here should match that line right there. Union all select star from A where A dot ID not in select B. It's not A dot ID, it's basket A. This is basket A not in select basket B dot ID from B like that from basket B. If I run this command as it is, you'll see that it gets no results down here because this basket A.ID not in these results right here. 1, 2, 3, 4, 5, null, 6, null. We're getting a, I want to include the null rows on the left-hand side here where, sorry, I'll just write out what the correct syntactic sugar is here. And the A.ID is not, is null. I forgot the is null here when I was writing this because the intuition over here is this, we're not including everything. But we also need to catch the things that are null. In the Pagilla homework, there are no null columns, null values in any of the areas of interest. And so this simpler syntactic sugar worked, but you need the and the ID is not null there. And basket A.ID is not null. Break this up into a readable thing. Run these two, just this bottom select statement right here. this will give us the semicolon. Sorry, or basket A is not null. Or basket A is null. There we go. Star space OR is null. Run that, semicolon. That gives us those extra rows that were appearing in the left join. And now that thing right there is this thing right there. You must have the same number of columns. Select star from basket A, comma, null, comma, null. There we go. These last two columns here were the columns coming from the this select statement right here. These are the things that are in basket A, but were not inside of basket B, but still are related to this join condition right here. And so they're getting included in the left join. This one has, this version of the left join has a little bit more intuition to it, that you're including all of the things that didn't get included in the inner join. But it's still something that I have to really think about every time I'm using the left joins. The rest of the quiz here is just variations on the left joins. And so the way to solve them is just by desugaring and then applying, for example, where clauses where appropriate. We'll pause here today. I'll take questions afterwards, but we're out of time. And so we'll stop here for today. If anybody has any questions, I'll stick around as long as you all have questions.